we're going to continue looking at breaking down radicals and simplifying them. A couple examples with just radicals, and then a couple examples with values on the outside of our radical, and just watching what happens there. So as we are breaking down radicals, we are going to use our prime numbers, so 2, 3, 5, 7, 11. And for the most part, most of the radicals that we'll be dealing with, we'll just use these prime factors and nothing really larger. So we're going to be moving from left to right, or from our smallest value up. We are going to find all of the 2's that we can by dividing by 2. Once we've run out of those, there will be no more 2's that we can divide by. We'll look for 3's, 5's, 7's, or 11's, and we work our way down. So then we'll look for 3's if there are none, then we'll look for 5's. If there are none, then we'll look for 7's, so on and so forth. So starting with 98, I'm going to start with my 2. And so I'm going to just divide by 2. So 98 divided by 2, if I divide that by 2, I'm left with 49. So 49 divided by 2. If I try that, I get a decimal. So 49 is not divisible by 2. So then my next thing I'll look for is 3. 49 divided by 3. If you punch that in a calculator, it's probably the way that most students would be doing it. You would find that 3 does not work. Okay, 49 divided by 5. If you divide that in a calculator, 49 divided by 5, you would find that 5 does not work. 49 divided by 7. And that one does work. 7 and 7. 49 is one of our perfect squares. And then 7 does not break down further. 7 is a prime factor. That's why it's listed up here. So because of that, we don't have to worry about breaking those down into 1's and 7's because these are our prime factors. So now I'm looking for groups of 2. So I find a pair here, which means I'm going to write one of those numbers outside. And then the 2 is still stuck inside. We use the 49 up to create 7 times 7. So the 2 is still inside the radical. All right. Here's another one. I'm going to use the same process. 2, 3, 5, 7, 11. And starting with 2, I'm going to see, can I divide this by 2? 200 divided by 2 is 100. So I'm going to give you the option here. If you notice that 100 is a perfect square, you can use the perfect square value, 10 and 10. Look, because then we've made a group. 1 gets caught, 1 gets outside, 2 stays inside. There's our answer. So you could use the square root of a perfect square if you find a perfect square. I could have done the same thing over here. 49 was a perfect square. I could have just jumped to my perfect square value. I'm going to show you had we have not broken it down. So breaking it down, we ended up with 10 square root 2. That was our answer. I'm going to come back here, and instead of using 10 and 10, instead of using my perfect squares, I'm going to continue to use a 2. So I'm going to break 100 down into 2 and 50. And then I can break 50 down into 2 and 25. And then I can break 25 down into 5 and 5. Right? Because 2 wouldn't work, and 3 wouldn't go into 25, but 5 does work. So now I'm looking for pairs. I have a pair of 2's here. I have a pair of 5's here. So remember in my pairs, the way that I do it is I just I cross one out and then I use the other one to go outside. I cross one out and then I use the other one to go outside. That way I don't write 2 of them outside or do anything funny like that. The only thing that didn't have a partner was this 2, so it's still stuck inside. And so 2 times 5 is 10, square root 2. So we still get to the same answer, but it's a different way. So for this one, we just took the square root of 100 was 10 with a 2 left over. This other one, we broke it all the way down and then multiplied it back up. Okay, if we have a number waiting on the outside, it's going to get multiplied back in our end answer. So here's what I'm going to do. I'm going to take this -4 so that I don't forget it. I'm going to write it over here. And it's going to be multiplying with any other numbers that come outside of my radical. But I'm just going to set it over there so that it's waiting, so that I don't forget it. We have our prime numbers that we're using, 2, 3, 5, 7, and 11. And then we're going to start by using our first prime number, 2. We're going to see, can we divide this by 2? So 128 divided by 2, you'll find that 64. And then 64. So again, this is either you can identify 64 as 8 times 8, because it's a perfect square, so there's my group. 1 gets shot, 1 makes it out, and a 2 is left inside. So 64 was 8 and 8. So there's my partners, 1 shot, 1 makes it out. I don't know why I wrote it over here. And then square root 2 stays inside. We can multiply up our outsides now. -32 square root 2 would be my answer. That's running into a perfect square and being able to use it. If you didn't see a perfect square and continue to break it down, so all of this work here, here's my answer, but all of this other work here was just because I hit that perfect square. I'm going to break it down further just so that we can continue to see it. So 64, let's say it's 2 and 32. And then we have 2 and 16, 2 and 8, 2 and 4, 2 and 2. So in this case, I never got past using 2's. 2 worked for everything. I didn't have to use 3, 5, 7, or 11. So now I'm going to look through and I'm going to find pairs. Remember these numbers on the right, if it helps, you can kind of scratch them out. That way we can see what we're really working with. So I'm looking for pairs of 2. For every pair of 2's, I'm going to write 1 outside. So there's 1, 2. Actually, you know what? I know this is going to seem like backtracking, but remember earlier I wrote this -4 outside that was waiting, so I'm going to have that waiting still. Okay, so then I had a pair of 2's, and then here's another pair, so I get to write another one, and here's another pair, so I get to write another one. If I used up all my pairs, I just wouldn't have anything to write on the inside, so I wouldn't write a square root in my answer. In this case, I have a 2 left over, so that one's still stuck inside. So now we're going to multiply all these up, and it's however you want to do it. I'm going to do -4 times 2 and get -16. And then I'm going to do -16 times times 2 to get -32. Then we'll multiply these up to get -64 rad 2. Oop. Sorry, I did something crazy. I did do something crazy. 4 times 2 is not 16. 4 times 2 is 8. I got ahead of myself. So go back and check your work. That was an 8. That was a 16. I don't know what I got into there. Negative 32 rad 2. So that way works, and all of my numbers were correct, but when I went back through and multiplied, I lost it. And really what I prefer to do is I would prefer to multiply all these 2's up, because I know that 2 times 2 times 2 is 8. And then I could do that times 4 and get 32. All right, let's move on from that. Number 22. Again, I have a negative 4 waiting outside. I'm going to break 72 down. Remember, I'm always looking for 2's, then 3's, then 5's, then 7's, then 11's. So I'm going to see if I can use up all my 2's first. So 72 divided by 2. 2 goes into 7 3 times with 6 left over, or with 1 left over. That makes 12, so 36. Again, 36 is a perfect square. 6 times 6 is 36. So we could just say 4 times 6, square root 2. Work this out, right? 36 is 6 and 6. And then multiply those up to get negative 24 rad 2. And be done. If you didn't see the perfect square, you can continue breaking it down. 2 and 18. 2 and 9. 2 doesn't work for 9. 3 does work for 9. 3 times 3. And we can't break it down any further. So I'm looking for groups. So there's a pair. There's a pair. This one's going to be stuck inside. So I have a 2 that gets written outside. Well, I have a negative 4 that was waiting, right? And then a 2 that gets written outside, and a 3 that gets written outside, and a square root 2 that stays inside. So negative 4 times 2. Make sure I got negative 8 this time instead of whatever I did. And then negative 8 times 3 is negative 24, square root 2.